How do you find local max and mins? Well, you find critical numbers first, and you do that by solving for what points x comma y is this partial derivative and this one both equal to 0 at the same time. And those points are called critical numbers. And then you test each critical number using this relationship here. And if the second partial derivative with respect to x is negative, and this guy is called d, this expression here, and if capital D is also positive, so capital D is positive, but the second derivative of it with respect to x is negative, then you're looking at local max. If you switch places, still positive, but this time this is positive, then you are looking at a minimum, which is very equivalent to Calc 1, the second derivative test, where f double dashed of x, if it was less than 0, would be a max, and it would be a min in that case. And then you get the kind of what's left over situations. Well, basically what's left over is that the d value is 0 or negative. And if it is 0 or negative, you really don't know for sure what's happening. The vast majority of the time, it's going to be that funny little shape that looks like a saddle point, right? That 3D surface where in one direction it's curving this way, but in the other direction it's curving that way. We call those saddle points. And if you get this third situation, you're really meant to go into some graphing software and just look at the function. And if you see a saddle point, then you know it's a saddle point. And if you don't, then it's a max or a min, and I guess you'll see that. So what I'm going to do now is just go into the algebra of solving these kinds of questions. Once we've done a few of these, probably take most of today, then we'll look at absolute max and min questions as well. Because these are just localized hills and valleys, but wouldn't it be nice if for the entire function, or at least a region of it, you could find the place where it is the absolute maximum height or maximum depth. Okay, so here's a function that we're going to find out all the cool things about it. First thing I'm going to do is find the partial derivative with respect to x, which is, oh darn it, already up to mistake. There we go, negative 4x cubed plus 4x, and that has to be 0. I would probably pull out 4x and rearrange things. Is it okay for me to swap places and rearrange it just so it looks pretty? Are you okay that that line is the same as that? If you look at it carefully, 4x, take away 4x cubed, and then pull out 4x as a common factor. Now, if I do the derivative with respect to y, we really don't get very much. Now, if both of these are going to be true, this one's very easy to solve. Won't the y value be 0? And in this case, the x value could be 0, it could be 1, and finally it could be negative 1. So when you put this together, there are 3 critical numbers, and they are 0, 0, 1, 0, and negative 1, 0. Are you comfortable about how I found those 3 critical numbers? Yeah, okay, so that's like if you want to call it a step, that's step 1. Now what we're going to have to do is find all the second derivatives that we need for, oops, that's my next question, and that's going to be my one after that, so I'll put them away for the time. And now we're going to take this guy, and we're going to find his second derivative with respect to x, and I get that. I'm going to take this guy and get his second derivative, and that's just negative of 2. And if I take this guy, but then I differentiate this guy with respect to y, I get 0. So I need to know that guy, I need to know this guy, and I need to know this guy. because they are going to give me D. And D is this fella times this fella, take away this fella. In this case, I'm going to have that guy. Going to have that guy. Take away nothing. Right. So I don't really need to use that, although I did write it down. I'm now going to test each of my points. Let's do 0, 0. At 0, 0, this fella is 4. At 0, 0, D is that guy, which is this fella, which is 4, times FYY, which is what, -2. Take away this guy squared, and I get -8. At 0, 1, this guy is 4. This guy is -2. This guy is 0. So D is
Wait, shouldn't it be
something's
1,
not right.
0? Shouldn't it
Thank
be
you.
1, 0? Because
Yeah. I was wondering why I was getting the same answer, and I was posing. Right, let's try 1, 0. Right, the second derivative is at 1, 0 is -8. This guy is -2. This guy is 0. So D is going to be this fella times this fella. Take away that guy squared, which is 16. And I forgot to do something. I've got the test point. I should decide, based on these two numbers, what the heck's going on. In this case here, isn't the D value -8, which is definitely less than 0? Doesn't that make it situation 3?
Yes.
And the thing about situation 3 is we don't really know. Can you trust me that if you go into 3D plot or whatever you use, can you just trust me that it ends up being a saddle point? You just pretend I went and looked at it. 99% of the time it will be a saddle point, but you know, the one time you don't check it, isn't that going to be the one time that it ended up being a max, right? Or something, right? So you know that's Murphy's Law. Every single time it's a saddle point, and then the one time you don't actually look at it is the one time you should have. But that one I know less, so I'm not going to go further. Right, what about this one? That's good news. That guy. If D is positive and the second derivative is negative, what are we looking at here? Local max, local min.
Local max.
Okay, so we're looking at local max. And that's going to be at the point 1, 0. And there's something I'm going to add on to this in a minute. And that's its value. But I'll come back to it. Now, if I do the last one in the set, which I believe is, where did I write my answers? Oh, is -1, 0. This guy here is, let's see what he's equal to. If you plug in -1 here, oops, if you plug in -1 here, you get that. This guy is that. This guy is that. D ends up being 16, it ends up being positive again. In this case here, the second derivative is also negative, so you have another local max, but this time at the point 1, 0. So what's that going to look like when you do it in WebAssign? You're you're going to have a box. I think it's called local max. And it's a guy here called local min. Actually, it has local max values, local min values. And then it has saddle point. And it goes X, Y, Z. So you might get the answer right, but you might not write it the way they want it to be written. So let's take the saddle point. Now, the guy that we found out that was a saddle point had an X of 0 and had a Y of 0. You also put into that what the Z coordinate would be, which would be 4. So for a saddle point, you put in the X, the Y, and the Z coordinate as a coordinate. So that's what they want you to do here. For the local max and min, you don't put in the coordinates, which I think they should either all do it or not, but that's not what they wanted. So we have a local max at 1, 0. Well, at 1, 0, this fella here is 4 take away 1 plus 2 take away 0, which is 5. So you only put in, oops, what was that, local max or min? Which one was that? It was, I get too many pieces of paper here. It was, oh good, it was a local max, the right place. And you put in 0, 0, and you get the value of 0, 0 ends up being 4, and that's where this one comes from. For the local max, you find the answer to the function, and the other one is this one, which ends up being, I believe, also 5. So the way in which you write your answers is a little bit clunky. I wish WebAssign had just said, give me the coordinates of the local max, give me the coordinates of the local min, and give me the coordinates of saddle point. But because it wants to, we have to do it. They only want the coordinates of the saddle point. And when it's a local max or a min, you just tell me the Z value, right? The value of the function.
So,
Now, if there was two local, yes.
or sorry, if we had 2 local maximums, would we just enter them with commas in between each number?
Yeah, you'd say there's one at 5 and one at 9. Yes. We're okay with that. I mean, I don't want you like do the hard stuff and then figure out why it keeps telling you that you're wrong. And it's really just you're wrong in the way that you filled in the boxes, not that you were wrong in the question, right? So a single number for local max, a single value of the function for a local min, and a coordinate whenever you have a saddle point. Now, I'm just scrolling through. Right. Can you imagine there might be a situation where one or more of these things don't exist, right? There isn't any local max. They want you to type in DNE. So if there isn't a local max and there isn't a saddle point, you fill the box in with DNE. You don't leave it blank, but you fill in with DNE, right? So that's
question,
what they want. Yeah.
Why does it say 5,9 for the local max when we have 2 local max?
I just
at 5,
added
5?
that 9 in because someone said, what do you do if there's 2 answers? So the correct answer for this question is just a single 5, another single 5, and a coordinate.
Okay, but we don't have a local min.
No, we don't. You're right.
We have 2 local max.
Yeah, so there we go. Third time lucky. Spent too much time telling you what to do and then not doing what I told you what to do. There are 2 local maximums. Technically speaking, do you think I need 5,5?
No, but they'll probably want it.
Yeah, have a shot at a question like that. If there's 2 local max, a 10. Try a single 10, and if it says it's good, then you can tell me next time. I don't, it seems strange, but I don't get to use WebAssign like you do. I get to use it as a professor. So there's things that you can do that I can't. If I go in under a student thing, it goes really weird on me. I'm not sure if it's my computer or what, but I end up getting kicked out when I try and answer questions. So I suspect strongly that if it's the same number, you just put in 1.5, even if it happens twice. That seems the most logical. Okay, let's go for this fella. Pretty much the same idea as before. Differentiate partial derivative with respect to x. I get 6x squared, take away 6, plus 6y squared. And that's going to have to equal 0. And then the partial derivative with respect to y in this case ends up being 12xy, and that also has to be 0. So I'm going to call this equation 1, I'm going to call this equation 2. And remember that both of these have to be true at the same time. And that is going to help us. I'm going to focus on equation 2. If someone says to you, what are the possible solutions to that equation? Would you agree they're quite limited? What are the two possible solutions out of 12xy equals 0?
X equals 0 and y equals 0.
Okay. Now what you should do is go to equation 1, put x equals 0, and find out what the values of y would have to be to make this also 0 at the same time. So essentially, I'm going to put x equals 0 into equation 1. So that's going to be 6 lots of nothing, take away 6, add 6y equals 0. Oh, can I just cut to the chase and say, look, a couple of lines from now, you'll be able to prove it's plus and minus 1. Can you kind of do that in your head? It's pretty straightforward what the solution would be. Now, what that has given me is 0, 1 and 0, negative 1. Here are two critical numbers, right? So we found two of them. And then I'll go back here and I'm now going to do the same thing again, but this time I'm going to put y equals 0 into equation 1. And let's see what that looks like. Well, it's going to look like 6x squared, take away 6, plus nothing equals 0. And can I also do a plus or minus 1? You can fill in the working. And what does that give me? Well, it gives me 1, 0 and negative 1, 0. So there are, in this question, there are 4 critical numbers, right? 4 critical points. At 0, 1, 0, negative 1, 1, 0, and negative 1, 0. Are we good? You happy about how I found those 4? Lindsay, you don't look happy. Have we got a question?
I'm wondering if there would be
Other possibilities?
well, if y can be plus or minus. No, never mind. I got it. Because we said,
Okay, we're
we
good.
said it. We said, okay, x has to equal 0, and that's what gives us the y. So we have 4 total critical points.
Yes, we're good now.
Yep, I'm good.
Right. Looks
Why
like you
wouldn't the
processed.
first one
Right.
that we solved as x is equal to 0 and y is equal to 0, why wouldn't 0, 0 be another critical point?
Well, if you plug 0, 0 in here, the answer is negative 6. It doesn't work.
Okay, gotcha.
It could have been, right? But that would have came up when I did this. You know, if I plugged x equals 0, y equals 0 would have popped up as one of the solutions if 0, 0 had been a solution anyway. So I wouldn't have missed if it did exist. Right, so let's do the partial derivative with respect to x, which we have. And that can get me this fella, who's 12x, partial derivative of y, which is this guy, and that gets me that fella, which is really weird. And I also need to know this guy, don't I? And this guy, I can do this guy with respect to y, or I can do this guy with respect to x. It looks like no matter how you do it, you get, that doesn't look good. Why am I not getting 2y?
I think, well, no, that wouldn't make a difference. There was a 6y squared on there. The in our f sub x, but I don't think that would make a difference for your f of double x. Then your f of xy was 12xy, and that would be 12x.
Oh, okay, here we go. I got it. If you do this guy with respect to y now, you get 2y. But if you do this guy with respect to x, you get 12y. That's what's worrying me. Shouldn't fxy be the same both times? Remember Clairaut's theorem, partial derivative xy is the same as yx. That's what's bothering me. So I'm going to go back and see why I can't count.
Well, you
This
had a
is the original
6xy
function.
squared in the original, so then you would have 6y squared at the first derivative of x. That's what you're missing on the other page. Is it's supposed to be plus 6y squared on the other side, other page, to your right.
Now we're happy. There we go. I just didn't write the 6. That's what went wrong. But you got to be aware when things don't work like that, so you can figure out what you didn't do. And the reason I paused on that is I was saying, how come this and this are not giving me the same xy, right? Because remember, xy, yx should give me the same thing. So I'm going to share a little piece of information with you. I'm going for the sympathy vote. I only have one good eye. I can't see a darn thing out my left eye, virtually. I'm sure I would be legally blind if my right eye keeled over on me. And I was born that way, so no big deal. But one of the things of only having one eye, I found is I have big problems scanning, which means if I look to the left and then I look to the right, I very often miss something, or I start looking at row 1, and then when I go back, I look at row 2. So sometimes I make some weird looking answers where it looks like I took a bit of this and then I did that bit. So it's interesting only having one eye. I have very little depth perception. You know, you need 2 eyes to have a good depth perception. So I miss door handles. It's quite funny. Parallel parking is a nightmare. I've never seen a 3D movie. I've been to 3D movies, you know, the ones you wear the funny little glasses, but I've never seen a 3D movie because you need 2 functioning eyes, don't you? And it doesn't work. So have I got enough sympathy points there? Right. So the second thing is I'm very careless. So I can use both of those at the same time as an excuse. Right, return back to this guy. Let's choose one of the points, just randomly this one. The second derivative at this point is 0. And the D guy is equal to nothing times nothing. Take away 12 squared, which is negative 144. Okay. can you see that this guy is the dreaded negative d value? And negative d values mean we don't really know. Can you trust me that it's a saddle point again? Because I happen to know that it is. And that's that one. So I don't spend forever in a day, because these take forever. Can you imagine I tested this point, I tested this point, and I tested this point? So I could, and this is me just making it up now, we could find out that at these 2 points, it was saddle points. At the point 1, 0, can we pretend it was a local max? And at the point -1, 0, we pretend it's a local minimal. And just pretend that I did these, right? And I'm not saying it is, I'm just doing it as a placeholder because it takes us 20 minutes to finish this question. Then for the 2 saddle points, won't you write in their full coordinates? So you would write in 0, 1, and 0, 1, 0, and 0, -1, 0. You would write the coordinates. And for the local max and the local min, well, you'd plug in 1, 0, and you get whatever your answer is. And then you plug in -1, 0, and you get what your answer is. Now that I'm looking at that, I can actually tell you what they will be. So at 1, 0, you are going to get -4. And at -1, 0, you are going to get 8. And for the local min and the local max, you just write down what the coordinate, the z coordinate would be. Are we good with that one? It's really a case of filling in the dots. So I'm trying to do the process here rather than doing the entire question. All right, here's one with trig. A little different with trig. Very often you're given constraints to put on the x and or the y. In this case, the x can only take values from 0 to 2 pi. Right, partial derivative with respect to x is going to be -5y sin x. Partial derivative with respect to y is going to be 5 cosine x. And these are going to be our 2 guys. Right, let's go looking for critical numbers. Any suggestions for how to go about finding any of the critical numbers? Because I'm pretty sure there's a few of them.
I guess we could use our.
This has to be.
Oh, sorry. We could use
Bit loud. No.
our trig knowledge and figure out where sine of x is equal to 0, and those would be points where the whole thing was equal to 0. So that would be pi over.
So that. So that'd be 0. There'd be pi, and there'd be 2 pi. Agreed? Wouldn't sine x be 0 at 0, pi, and 2 pi? Right. We also need to look at for each one of these x's, right? Doesn't it need to be true here as well? And if you plug in 0, you plug in pi, and you plug in 2 pi, none of them work. But that's okay. If I return to this one, couldn't y be 0?
Yes.
Now, I don't have anything to compare y with, so that makes life easy. That means y has to be 0. So whatever the x is, it's going to be 4, 0, it's going to be pi, 0, right? Now, what about 5 cosine x? We haven't tried that yet. Well, doesn't that end up being cosine x has also to be 0? And if you think about where does the cosine equal 0, isn't one of the places there and isn't the other place there. Now, if you look at these two, they make this 0. If you look at these two and you plug them in here, won't it be 0 as long as this guy's 0? So it does mean that I found two critical numbers. They're pi upon 2, 0 and negative pi upon 2, 0. Do you follow the logic of how I found those critical numbers? And the key to getting them is that both things must equal 0 at any given point. If you plug x is pi upon 2 and y is 0, in here you get 0, and in here you get 0. So I know it works. And if you do that one, you'll get the same. Why am I saying negative pi upon 2? There we go. 3 pi upon 2. And this one. There isn't any other combinations. These three were candidates, but they get killed on equation 2, right? They didn't work on the second equation, so we threw them out. So you might have 10 candidates, but you might only have 2 that succeed, right? And those would be the two critical numbers. At this point, I'm only going to do a setup and then dot, dot, dot it. So this guy is negative 5 sine x. So his second derivative is going to be negative 5y cosine x. And this guy is 5 cosine x's. And the second derivative is going to be negative 5 sine x. And then the xy guy, interesting.
Negative 5 sine x. Yeah, they would
Correct.
be the same.
They will be the same. I was hesitating there because one of them didn't make sense in my head, but it was me not doing it right. So can you imagine at that critical number finding D and finding that guy? And if you find D and you find that guy at this critical number, won't you get one of three things? It's a local max, it's a local min, or we don't know. And the don't knows are almost always saddle points. And then you do it for the second one. And dot, 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 right? That would be something that you would fill in. Have you noticed that these questions involve a little bit of unusual solving equations at the beginning to find the critical numbers? There, with exception of maybe some of the polynomial questions, they are not, each one's slightly different, right? You have to kind of, yes.
Professor, I have a question. Go back to partial derivative of f over y. You got 5% of x, correct? Partial derivative of f over y. You got 5% of x right there. Down.
Yeah.
So the second partial derivative of that should not be 0.
Yes.
Okay.
My brain is thinking far too ahead for its own good. But everything else I said is still true. I'm glad I did dot, dot, dot. Can you imagine we spent another 15 minutes doing it and then wondering why it wasn't going to be the answer I was expecting? So let me randomly pick a guy. This is similar to question 7. It's x cubed plus y cubed, take away 3x squared, take away 9y squared, take away 9x. And I'm only going to do the point where we'd start doing dot, dot, dots, right? So I'm not going to do the whole question. Right, for this question here, then, the partial derivative with respect to x is 3x squared, take away 6x, take away 9, and we know that must be 0. And the partial derivative with respect to y looks like 3y squared minus 18y equals 0. And the goal is to find combinations of x and y where both of these derivatives are 0 at the same time. Now, each one, as I said, is kind of unique, so you take it, you take what you get. If you take equation 1, I like equation 1 because everything is in x's. That makes it easier to solve. If I pull out a 3 as a common factor, then I should be able to factor this very easily. Which means x equals 3 and x equals -1 are candidates for the critical numbers. You agree? Now, if I look at equation 2, which is this one, and I pull out 3y as a common factor, I get y equals 0, and finally, y equals 6. Now, if I make x equals 3 and I make y equals 0, won't that work? Because they're kind of independent of each other, I know that as long as I do that, that tells me that there's actually 4 critical numbers.
So in this situation, if you find the 2 values of x and 2 values of y, you have to plug each value of y per each value of x into the equation to see if it would work, the different coordinates, right?
Yeah.
And equal that 0.
Yeah. Yes. And if you are lucky enough that each equation only contains one of the 2 variables, you don't even need to do the check because it's guaranteed to work. But if this has some x, y's in it and this has some x's and y's in it, then what you just said is exactly what you needed to do. You would plug x equals 3 in here and see what you would need to make it work. Maybe it'll work, maybe it won't, right? If it doesn't work, at least it would tell you what the y would need to be to make it work. Okay. Now, at this point here, I'm going to do my ... Won't we just find all the second derivatives that you need and then do your test? Since there's 4 guys, it wouldn't surprise me. Actually, I'm looking. There's going to be 1 max, 1 local min, and 2 saddle points. So you write down 2 separate coordinates with a comma between them. Are we good with what at least I've done? You feel comfortable with it, right? Polynomials are the easiest things to do derivatives of. They just take time. Scroll a little bit further. This is question 8. Going to be careful with question 8. I can see right now there is going to be and the reason I'm saying is that this is worrying me. It might just be an idiosyncrasy of WebDesign, but when I look at this equation here, it's got a trig guy in it. If you're going to restrict the x's, wouldn't you expect the restrictions to be, I don't know, 0 to 2 pi or minus pi to plus pi? I'm just wondering why it's these 2 numbers. So I guess I'm going to find out in a minute. If you do a partial derivative with respect to x, you'll get nothing for this. That gets you a negative, so it's positive 10 y sine x. If you do a derivative with respect to y, you get a 2y negative a 10 cosine x. And we want these both to be zeros. And I'll call this equation 1, I'll call this equation 2. When I look at these 2 equations, very often there's a decision to be made, which is which equation you should work on first. Which one's going to help you get the answers that you need? And I'm pretty sure I know which one of these two I'm going to start with. Should I be looking at one to get solutions or two?
One.
Use one.
Yeah. Would you agree that two have got X's and Y's mixed up in a very ugly way that I'm not sure how I could tell you what number Y is or what number X is? So if you take this fella here and you make him 0, one of the possibilities is Y equals 0. And the other possibility is going to be this fella. And since I'm only going to do it from -1 to 7, won't that be X equals that fella, X equals that guy, and X equals that guy? Okay. And these three guys are all between 0 and 2 pi. I wish they had just done that just to make my brain feel happier. I mean, I just don't know where the 1 and 7.
Yeah, exactly.
Are we good? Right. Now, focus on Y equals 0. So I'm going to put Y equals 0 into equation 2 and see what the X's need to be. And when we put them together, they will be critical numbers. So I'm going to get nothing out of that. And -10 cosine X has to be 0, which means cosine X has to be 0, which means X will have to be pi upon 2 and 3/2. And now I have some critical numbers. If you make X that guy and Y 0, and you make X this guy and Y 0, both of these will be 0, right? So you can check it. Plug that into here, plug that into here, and both are 0. Do the same with my second combination, both are 0. The reason I know that this is going to be 0 is won't the Y equals 0 can it automatically make that work? And making these for the X's will make that work. Now I have 3 more possibilities. And I'm going to take each one in turn and see what we get. If we plug X equals 0 into equation 2, which is this guy, we get 10 times the cosine is 0 has to be 0. And that's 1, so we get that has to be 0, which means we get that, which means we get that. So that means I now have another critical number, 0, 5. If I plug X equals pi into 2, we get 2y take away 10 cosine pi is equals 0. 2y -10 times -1 equals 0. 2y is -10. Y equals -5. So that gives me pi with a -5. And lastly, 2 pi. And if you do 2 pi again, can you trust me that you end up with 5 again? So there are 5 critical numbers. Wow. That's a lot of critical numbers. Well, every single one of them you test. Some of them will be saddle points. Some will be a local max. Some will be a local min. And you know it's possible that a couple of these are going to be D less than 0. And you plug it in and you look at it. And this, I think, is a good candidate for that one situation in 99 where there isn't anything happening there. You'd expect to see a saddle point and there's nothing going on. In which case, let's say it was that critical number, it doesn't get used. Remember, if D is negative, we don't really know what's going on. It's the kind of the hole in this process, right? Where just some combinations just turn out weird and we really won't know what's happening until you drew a picture and you say, okay, if I was at 2 pi on the X and 5 on the Y, if I look upwards at that point, is the curve a hill, is it a valley, is it a saddle point, or is nothing really happening? And if the answer is nothing really happening, that critical number isn't a local maximum or saddle point, and we ignore it. Are we good? So let's say hi for attendance.